Hi, I want to tell you about my new car. See, my new car is really fast. It'll go from 0 to 60 in half a second. It'll break the sound barrier in 10 seconds flat. And it'll take me anywhere I want to go on the planet in about 30 minutes. I took my new car for a test drive and it was great. It was exhilarating, the ride of my life, but I couldn't help but feel a little bit cheated afterwards because all that was left of my car after I took it out was the steering wheel. What happened to the rest of my car? Well, my car's not a normal car. It's actually a space rocket. Have you ever seen a rocket? They're huge, hundreds of feet tall. However, only about 5% of what you see on the launch pad actually makes it to orbit. About 85% of the rocket is required to be fuel. Now imagine I'm in orbit around Earth with my steering wheel, and I really want to go to Mars. How do I do that? Well, I could launch several more steering wheels into space and lasso them all together to build a rocket big enough to go to Mars. Or I could build a gigantic rocket that would make the Empire State Building look small. That would launch a gigantic steering wheel that would be big enough to get to Mars. But I have a better option. Have you ever driven a manual car? You start out in first gear, then shift into second gear, then shift into third gear. The lower gears are for power and the upper gears are for speed. For rockets, first gear needs to be able to overcome Earth's gravity and atmosphere without crashing the rocket back into the ground. Traditional liquid and solid rockets that you see in the movies are perfect for first gear. But once you're in orbit around the Earth, the environment is different. You can now shift into second gear. And second gear is electric propulsion. Can you imagine getting 400 miles per gallon in your car? That's about 10 times more than some of the best cars on today's market. And that's about the difference between traditional liquid and solid rockets and electric propulsion. These electric propulsion engines are great. They've already been used to send probes to several asteroids and the moon. But there is a drawback. Electric engines require electricity, and a lot of it. If you don't mind taking years to get to Mars, you can use a simple solar panel. But to support manned operations to Mars, you really need something bigger. Have you ever opened a Christmas present that needed batteries that you didn't have? Well, that's exactly what electric propulsion is facing. The engines have been developed, but the power source is lacking. And that's where my research comes in. I'm working on developing new nuclear reactor designs to empower a new generation of rockets that can open the solar system to rapid, reliable transportation. Thank you.